Good morning, children. Today we will take another application of the differentiation. Last classes we have discussed the application of derivative. One is the rate of change because it was deleted, but you should have a basic idea about the rate of change. And another one are differential approximation, that is also deleted from the syllabus for the present year. And the other third one what we have studied is finding out the increasing and decreasing intervals of the functions, how the different derivative can be used. Now the next one here is equation of tangent and norm. For this you require a lot of the basic ideas which you have studied in class 11. You have studied a chapter that is called the straight line chapter. There you studied what is slope, and you have studied the equation of the straight lines, different forms. You have studied equation of the straight lines, different forms. So first let us discuss about the equation of the straight lines which you have studied in the class 11. And one form of the straight lines which is you have studied is y minus y1 is equal to m into x minus x1. Y minus y1 is equal to m into x minus x1. This is equation of the straight line passing through a point x1 y1 having the slope m. So equation of the straight line, we call it as a short form, the point slope form. Equation of the straight line passing through a point x1 y1 and having a slope m. It is the y minus y1 is equal to m into x minus x1. Now how this is connected with our present topic geometrics, let us see. And this is also you have studied, that is if p is equal to x1 y1 and if q is equal to x2 y2 are 2 points, then the slope of pq is equal to y2 minus y1 divided by x2 minus x1. Difference of the ratio of the difference of y coordinate divided by difference of the x coordinate is the slope of the line. And this is also you have learned that a slope is equal to tan theta. If theta is the angle that it makes the positive direction of the x-axis, then slope is equal to tan theta. So these are all the things which we require, the basic ideas which we require for studying this topic. Now you know that f dash x is equal to limit h tending to 0 f of x plus h minus f of x divided by h. This h I can write this as x plus h minus x, because x plus h minus x gives h itself. Now this is what the derivative definitions. Now let me draw geometrically, let me show what is it means. As theoretically it means it is the rate of change of a variable. Say if I say y is equal to f of x is the function, the rate of change of a variable y with respect to x is called the derivative. That is what the theoretical mean. And let me explain what is the geometrical interpretation of this derivative, how it comes. Let this be the curve of y is equal to f of x. Okay. And let me take a point here p xy and here another point qxy. And when you say y is equal to f of x, then this is actually what? F of x. Y coordinate means it. And here another q1 x1 here taken. I will take x plus h as the other coordinate. So then I can call it as f of x plus h. The reason means this is x coordinate, no? The distance from, when you drop the perpendicular to the x-axis, the distance from origin to that foot, that is the x coordinate of the point, and this is y coordinate. What is that? Y coordinate is f of x, y or f of x. And now you drop the perpendicular here, and this is, what is this? This is x plus h. And what about this distance? That is f of x plus h. This is the coordinate geometry which you have studied in class 10 also, and continuation you have studied in class 11. So now this is P. X f of x. Okay. So let me join this. This is P and this is F. Now I have written the equation of tangent and normal. You have studied in class 9 what is the tangent. Don't confuse with the sine, cos, tan. That tangent, no. It's the geometry tangent. Geometry tangent means it is a line segment which line which touches the a curve in single point, or if a line intersects a curve in a single point, we call it as a tangent. This is a tangent, and this is chord. It intersects the curve in 2 points, we call it as a chord. If the line touches the curve in single point, we call it as a tangent. The other one is called the chord. These are the basic ideas which you have learned in the geometry in the lower classes. Okay, now see here, I can call this PQ as the chord because it intersects at 2 points. Now, when you take here in this definition, how we can link this derivative with this chord and tangent, that is what we want to know. Now, f of x plus h, what is f of x plus h? It is the y value of this q coordinate, and f of x, it is the y value of p. So, difference of y coordinate divided by difference of x coordinate. So difference of y coordinate divided by difference of x coordinate, that is y2 minus y1 divided by x2 minus x1. We know it is slope, and you can see that when h tending to 0 is there, the derivative h tending to 0 is there. When h tending to 0, what happens to this q? I have taken first x and then I have taken this as h, an increase. So f of this is x plus h. And f of x plus h is its corresponding y value. When h tending to 0, what is going to happen is slowly this q is going to coincide with the p. When h is becomes 0, p and q becomes 0, the same one. When h is equal to 0, the coordinate, the point q and p will become same. So when h is tending to 0, when h is very near to 0, you can see that the q is going to be coincide with the p. So the chord PQ will become the tangent at that point. PQ will become the tangent at this point. So we can say that this is actually the tangent. The tangent of which one here? PQ becomes the tangent. So we say that f dash x is actually geometrically, when we interpret, it is the slope of the tangent. F dash x is the slope of the tangent, or we can say it is the dy by dx. So dy by dx, the geometrical interpretation of dy by dx is the slope of the tangent. That is to be made correct, concrete. That is dy by dx is the slope of the tangent. So with that idea, let us go to now the equation. Slope equation of tangent you want to find out. Y minus y1 is equal to m into x minus x1 is the equation of a straight line. which passes through the point x1 y1 and having the slope m. That is this equation gives. So if I take y minus y1 is equal to, in place of m, if I take dy by dx, dy by dx is the slope of tangent. So it becomes equation of the tangent. If m is the slope of a line, that is the equation of a line. This is the equation of the line. If I replace this m by slope of tangent, because we have just now explained that geometrically dy by dx is the slope of the tangent. So y minus y1 is equal to dy by dx into x minus x1 is the slope equation of a tangent, and dy by dx at x1 y1 is to be taken. Dy by dx at x1 y1, because when it is h tending to 0, it closes and it becomes a tangent at this point. So dy by dx at x1 y1 will get. So this will be taken as the equation of the tangent. Y minus y1 is equal to m. This is the m slope. Y minus y1 is equal to m. That m is dy by dx at x1 y1 into x minus x1. This will be the equation of the tangent. Now let us come to the point, what is a normal? See, here you can see that this is a tangent. A line which is perpendicular to the tangent is called the normal. A line which is perpendicular to the tangent is called a normal. So now if you, this is the slope of the tangent is dy by dx. And what will be the slope of this normal? If you write in here m as the slope of the normal, you can call that as the equation of the normal. Now, one more result which you have studied in the class level is, if m1 is the slope of a line and m2 is the slope of another perpendicular line, that is m1 m2 is equal to minus 1. This is a result which you have studied in class level. If m1 is the slope of a line and m2 is the slope of another perpendicular line, then it is product will be always equal to minus 1. So from there, what you get is m2 is equal to minus 1 by 1. So the slope of a perpendicular line is equal to minus 1 by the slope of the other line. So if you know, if this 2 is the slope of a line, then its perpendicular line slope will be minus 1 by 2. So remember this result, m1 and 2 is equal to minus 1. If two lines are perpendicular, and we have just here explained that a normal is a line perpendicular to tangent. Say this is a line and then this is the tangent at this point at x1 y1, and then this is the normal at x1 y1. So y minus y1 is equal to m into x minus x1 is our basic thing. It is equation of a line passing through a point x1 y1 having slope m. Then y minus y1 is equal to dy by dx at x1 y1. Dy by dx at x1 y1 gives the slope of the tangent. Dy by dx is the slope of the tangent. It gives the equation of the tangent. Okay. Now equation of normal. How it comes? Equation of the normal, I told you that normal is a line perpendicular to the tangent. Okay. So y minus y1 is equal to minus 1 by, I have told you that if m1 is the slope and the perpendicular line slope will be minus 1 by m1. So dy by dx is the slope of the tangent, and we have explained that normal is a line perpendicular to the tangent. So minus 1 by dy by dx at x1 y1 into x minus x1. Y minus y1 is equal to minus 1 by dy by dx at x1 y1 into x minus x1 gives the equation of the normal. So equation of the tangent, equation of the normal. These are the two things we have to remember. There we are using dy by dx. So these are the another application of the differentiation where we find the equation of the tangent and the equation of the normal. I just repeat it. This is what are major things what you have to remember in this, what I explained now till now is dy by dx is slope of tangent. This is the major application. Here what x is slope of the tangent. So equation of the tangent is y minus y1 into y1 equal to dy by dx, that is slope, into x minus x1. Equation of the normal is y minus y1 is equal to minus 1 by dy by dx into x minus x1. So this one, that is the major things you have to remember. Okay, now I just give one or two questions. Suppose y is equal to x cube minus 3x square plus 2. Find the slope at 1, 1. The question is very simple. You are given a curve and you are asked to find the slope at 1, 1. You know that the slope is dy by dx. dy by dx is a slope. So dy by dx is equal to 3x square minus 6x, and dy by dx at which point you are to find the slope at 1, 1. So at this point x is to be taken as 1. So 3 into 1 square minus 6 into 1. So 3 minus 6, it gives minus 3. So this is the slope of the tangent. And what is the slope of the normal in that case? Slope of the normal. Slope of the normal is equal to, this is the slope of the tangent, minus 1 by slope of the tangent, that is minus 1 by 3. So that way you can find the equation of the, slope of the tangent and slope of the normal. Now I just give one question for finding the equation of tangent. Say x raised to 2 by 3, y raised to 2 by 3 is equal to 2. It is a curve given to you. Find equation of tangent at 1, 1. Equation of the tangent at 1, 1. First, what you have to remember, you have to write that formula. Equation of tangent. What is the equation of the tangent? Y minus y1 is equal to dy by dx at x1 y1 into x minus x1. This is the formula which we have used for finding the equation of the tangent. Here at 1, 1, so x1 y1 is given. This is x1 y1. Now we require this substitution dy by dx. So we should get a dy by dx from this curve. How do you find out dy by dx? Differentiate with respect to x. So what is the derivative of 2 by 3 x raised to 2 by 3 minus 1 plus 2 by 3 y raised to 2 by 3 minus 1 dy by dx. You are differentiating with respect to x now. Derivative of 2 with respect to x. Derivative of constant is 0. Now 2 by 3 can be removed. X raised to 2 by 3 minus 1. Y raised to dy by dx equal to 0. Taking to the other side. So y raised to minus 1 by 3 dy by dx is equal to minus x raised to minus 1 by 3. So what is dy by dx? Minus x raised to minus 1 by 3 divided by y raised to minus 1 by 3, or means negative. This is also negative. It will become y raised to 1 by 3 divided by x raised to 1 by 3, or it is negative cube root of y by x. That is dy by dx. Now dy by dx at the given point. What is the point? 1, 1. So dy by dx at 1, 1 is equal to, you have to put x is equal to 1, y is equal to 1, minus cube root of 1 by 1. That is so now what is the equation? Equation of tangent y minus y1 dy by dx at x1 y1 is minus 1. X minus x1. So it is y minus y1 minus x plus 1. and x plus y minus 2 is equal to 0. That is equation of the tangent. Similarly, the other problems also you can find out. So, thank you. Go through it thoroughly.